I'm I'm Santosh, Assistant Professor, Department of Petrochemical Technology, Excel Engineering College. I'm present at the topic is mass transfer and its applications and theories of mass transfer. Mass transfer is nothing but transfer of material from one homogeneous phase to another homogeneous. This is the main driving force is concentration difference. Mass transfer occurs in the gas absorptions, distillations, extractions, leachings, adsorption, crystallization, and membrane separations. So main driving force is concentration difference. Is a vapor phase and solubility and diffusivity is the based on the difference. Next one. This is principle of diffusion. Diffusion is a movement under the influence of physical stimulus and individual component of the gas mixer. This is a main one is diffusion. Diffusion is the concentration difference is the cause of diffusion. For example, removal of ammonia by gas absorptions. So first principle law means Fick's law. Fick's law of the diffusion. J is directly proportional to diffusivity into concentration gradient. J is equal to molar flux of the component A and dV equal to volumetric diffusivity and Ca equal to concentration and V is the distance of the direction of diffusion. Diffusion means one place to another place is a movement of molecules. Is a higher molecule to lower molecule or lower molecule to higher molecule is the molecular. Two types of diffusions are molecular diffusion and eddy diffusions are there. This is one of the main principle of Fick's law of the diffusions. So main thing mass transfer theories. Mass transfer theories means first theory is penetration theory, surface renewable theory and Higgs theory. This is a mass transfer theories is a turbulent flow is desired in the mass transfer operations. To increase the first one is to increase the rate of transfer per unit area. Another one is to help the disperse one fluid to another fluid. Third one is to create the interfacial area, more interfacial area to create to higher mass transfer coefficients. Mass transfer is a fluid interface. Second one is mass transfer is a fluid interface to obtain the unsteady state type. How to find out the mass transfer coefficient in the three theories? Is the first one rate of mass transfer per unit area per unit concentration difference. Kc equal to molar flux divided by concentration difference. Kc is the unit of velocity in meters centimeter per second or meter per second. Concentration is the moles per volume. This is the find out the mass transfer coefficient formula based on the theories. Theories means liquid or gas. Liquid and gas mass transfer formula means Ja equal to YAI minus YA. Is a moles per area into time. Moles per meter square into second. Y and X is the mole fraction in vapor phase or liquid phase. Y means vapor phase, X means liquid phase. This is the final formula of the Ky equal to Kc into rho into m equal to Kc into P by RT. This is gas phase coefficient formula Kg equal to Ja by Pa minus Pa. Kg equal to y, another formula Kg equal to y, Ky by P equal to Kc by RT. Based on the molar mass flux and based on the ideal fluids. There is three types of theories to find out the mass transfer coefficient. First theory is film theory, second one is penetration theory, third one is surface renewable theories. So first film theory is proposed on Nernst 1904. Nernst is postulated in the interface near the interface to exist in the stagnant film. Stagnant film is hypothetical since we really don't know the detail of velocity profile near the interface. The basic concept means resistance to diffusion can be considered for the equivalent to the stagnant in the stagnant film of the certain thickness. Next, the mass transfer occurs in the molecular diffusion based on the fluid layer of at the base of boundary wall, solid wall. This is the graph. Z is the distance between the concentration and Z versus concentration. This is the concentration profile. This is stagnant film is steady linear, and coaxial concentration profile is a decreased one, CAI minus CAB. This is the delta. Is the final flux is low, the mass transfer Na equal to minus DAB, though dCA by dEJ. This is the mass transfer formula. This is the boundary layer. Boundary fluid, bulk fluid is entered in the velocity profile is decreases, the interface stagnant film. This is the boundary layer. This is the mass balance of the film theory. The rate of the input, rate of the output, rate of the accumulation. Therefore equal to steady state Na equal to Na by Z distance minus Na by Z plus delta Z equal to 0. This is the equation. Integrating the equations, is the boundary condition CA equal to CAI. The finally Z equal to 0, CA equal to CAB transformed into replaced Z equal to delta. Z is Z by delta is replaced. Final equation Na equal to DAB is CAI minus CAB divided by delta. Is the final mass transfer coefficient KL equal to DAB by delta. Is the concentration profile is stagnant, film is linear. Second one is molecular diffusion. Therefore, X law is replaced in flux is through film. Film means J equal to minus D dou C by dou X. This unit is milligram per centimeter square second. Next, this is the another transformation of the thickness delta N is replaced by dou C by dou X equal to CB minus CI divided by dou N delta N. CB and CA is the concentration of bulk and interface. I is the interface. This is the steady state and no reaction in the stagnant film, no accumulations. This is the equation J equal to minus D CB minus CA divided by del N. So next one, Henry's law is applied in the concentration CA interface. CA equal to CG by HC. CG is the Henry's constant. Is the phlegm of liquid and the opposite side in the gas phase. This is the graph of distance from the interface and the concentration. Concentration, the hypothetical gradient is linear and the actual gradient is decreased in the increasing of the interface del N versus concentration. The problem of the model is effective diffusion coefficient is seldom constant. The turbulence does not enter in the film area. Another two theories, penetration and surface renewable models. Penetration, most realistic model is penetration is proposed on Higby 1935 and Danckwerts 1951 is surface renewable model. The bulk model, these models are bulk fluid packet eddies works the way of interface from the bulk solutions, while at the interface they attempt to equilibrate with the other phase under the non-steady state conditions. No film concept needed to involve. The concentration profile of the each eddies are determined by molecular diffusions. So this is the penetration theory. Basic assumptions. First one is unsteady state molecular mass transfer occurs in the liquids element, so along with the bubbles or other phases. Second one is equilibrium exists at the gas liquid interface. Third one is each of the liquid elements stays in the contact with gases for the same period of time. Third one is this is the schematic representation of penetration model. This is rising gas bubbles in the upward and remaining bubbles or liquids elements are sliding down. Dou C by dou T equal to D dou square C by dou X square. This is the equation for penetration theory. Next one is assumptions is solutions to be governed equation depends on the boundary conditions. Higby penetration models are assumed that the eddy does not remain at the surface long. Z equal to eddy means Z equal to ZB. This is the eddy behaves the semi-infinite slab. This is the interface between the slab. The first curve is linear, another is curved, just curve, another one is fully curved. This is the boundary condition T equal to 0, Z is greater than of 0, C equal to CAB. T equal to greater than of 0, Z equal to 0, C equal to CAI. This is applied in the penetration model. J equal to 2 into root of D by pi theta, Ci minus Cb. Theta is average time at the surface. A constant for the given mixing level. The mass transfer coefficient is given by KL versus time equal to root of DAB by pi theta. This is the second model. Third model is surface renewable model, is proposed by Dankworth 1951. This is the another model of Higby penetration theory with surface renewable model. It is mainly find out the mass transfer in the liquid phase. This is also find out the mass transfer coefficients. This is most motion of the eddies near the surface and proposed by the following assumptions. First assumption is liquid element at the interface are being randomly swapped by the fresh element from bulk fluids. Second one is at any moment each of the liquid elements at the surface has to same probability of the fresh element. Third one is unsteady state mass transfer takes place to a element during the interface. J equal to Ci minus Cb root of d into S. S means surface renewable rate. KL is the into average equal to root of S into DAB. DAB is the diffusivity coefficient of A and B. This is the comparison of the model Higby and Dankworth models. Both predict J is proportional to D power 0.5, and where Nernst film model predicts the J is proportional to D. That is enough. The actual observation shows J is proportional to D power 0.5 minus 1. There is a most complicated model. There may be experimental data is better. We don't need to involve them at this time. Thank you.